Our lesson for today will be looking at chemistry 1502. The topic for today is alcohols. Reactions, the main reaction we'll be looking at is oxidation. We are looking at lesson 102.1. Let us start. You should know that we do have different types of oxidant reagents. Oxidant reagents are actually the driving force for the oxidation of alcohols to different types of functional groups. We do have strong and weak oxidants. So what is important in this reaction is to know the different types of oxidants so that you'll be able to tell the product which will be formed. Now you should know that a primary alcohol, remember we're dealing with hydroxy group. Let me actually do this. A primary alcohol, if we use a weak oxidant reagent, you should know that the functional group will be aldehyde, actually form aldehydes if we use a weak oxidant. Then should it happen that we take the very same aldehyde we further oxidize using a weak oxidant, we are going to get a carboxylic acid. But you should also take note that whether we use a weak or strong oxidant, if we oxidize an aldehyde, we are going to get a carboxylic acid. Again, if we take a primary alcohol and then we use a strong oxidizing reagent, you should know that we are going to go straight to carboxylic acids. You'll actually skip the aldehyde production and go straight to carboxylic acid. For secondary alcohol, whether we use a strong or weak oxidant reagent, you should know that we always yield a ketone. This is very important. And then we know that tertiary, there's no reaction at all. Since we are dealing with oxidation whereby we add oxygen atoms, most of the oxidants, they contain oxygen atom. So one of the strong oxidants is potassium permanganate. We also have chromic acid. We have a combination of these substances together with acetone. It is known as Jones oxidation or oxidant. Sometimes in a reaction we'll simply write Jones oxidant. You should know that it's a very strong oxidant. You should know that these oxidants will actually take a primary alcohol it will oxidize it straight to carboxylic acids. if we use one of these oxidant reagents. We also have weak oxidants, which we use to oxidize a primary alcohol to aldehyde. The first one would be dichromate. It's actually dichromate ion. And then we have Collins reagent. Collins reagent is when we have with pyridine. It's also known as Collins reagent. And then we have one of the most common weak reagents which is used to oxidize a primary alcohol to an aldehyde, which is pyridinium chlorochromate. Sometimes you'll just see PCC. And then we have pyridinium dichromate. It's also known as comfort reagent. It's PDC. And then we have desmartin pyridinate. For the sake of mechanism, the molecular formula is C13H13, then there's iodine and O8. Then we also have another weak one, which is, you'll see the word DMSO, which simply means dimethyl sulfoxide. The molecular formula of dimethyl sulfoxide, it's S, as a central atom, and then it has double bond with oxygen, and then it has methyls here. For the sake of mechanism, this is the molecular formula. We also have oxyl. It's actually oxalyl chloride. The molecular formula is C2O2Cl2. Sometimes it is written like this, COCl, and then we have 2 here. You should know that when you multiply, removing the braces, you'll get the very same molecular formula that I've written here. I'm not going to dwell much on the stereochemistry, but the molecular formula is like this. Another most common oxidant that is used for production of aldehyde from primary alcohol, sodium hypochlorite. It is used with tempo. The name for tempo is tetramethylpyridinyl oxyl, and then the molecular formula is C9H18NO, in case you want to know the molecular formula of this, but I think it is not important. Then this is an oxidant that we can use to produce an aldehyde from a primary alcohol. And you should also know that this can also be used from primary to carboxylic acids only if we use excess of this. Sometimes it will be noted that we have an excess of this, and then what is the product? You should know that once we have an excess of this oxidant, we are going to form the product of carboxylic acids. And you should know that this method of using this reagent that is possible to oxidize a primary alcohol to aldehyde in excess to produce a carboxylic acid from primary alcohol, it is way better than using chromic acid to oxidize an alcohol, primary alcohol to be specific, to carboxylic acid. And then you should know that for secondary to ketones, we can use any type of reagent, whether it is weak or strong reagent. You should know that whenever we oxidize a secondary alcohol, we will form a ketone. In the next lesson video, we'll be looking at practice questions, whereby we'll be looking at questions with different oxidants, talking about the reaction, and then we predict the product that will be formed. That's it for this lesson video. This is Wakula SJ. Thank you very much.